For years, cinematographers tried to capture its steps with varying success. Witnessed at normal speeds, their fleet-footed water dance leaves nothing but questions in its wake. But slowing the action lets us see why this animal's become so famous as the Jesus lizard.
The Basilisk lizard has the ability to run across water up to several feet, unlike humans and other animals. Our group will discuss how the lizard can accomplish such an amazing phenomenon.
Our hypothesis is that the lizard exerts a propulsion force greater than its body weight to maintain the surface tension of the water. We believe that the lizard's feet generate large impulse forces, allowing it to stay above the water.
Our first analysis was if the surface tension was enough to keep the lizard on the surface of the water. So we found this equation: the weight equals the surface tension times the length. Weight equals mass times gravity. The average surface tension of water is 7.34 times 10 to the negative 2 newtons per meters. The average length of a foot of the Basilisk lizard is 8 centimeters or 0.08 meters. The average mass is 200 grams, so that's 0.2 kilograms. So by plugging all these variables into our equation, we find that the weight term does not equal the surface tension times the length. Therefore, we have come to the conclusion that there must be other forces involved due to the fact that the weight and surface tension times length do not equal each other.
Since the weight of the lizard is larger than what the surface tension will allow, we must account for the other forces taking place. We use the propulsion force equation to figure out the other forces. The propulsion equation accounts for a drag force, buoyancy, the weight of the lizard, and viscosity. For this equation, we need the width of the leg, which is just the length of the leg, the density of water, the height of how much leg sinks, so it's negative 0.05 meters, and then the viscosity of water. And when you type that all into that equation, we come up with a force of 58.57 newtons, which is the total force produced per leg.
So to conclude, the lizard exerts this propulsion force of 58.57 newtons per foot radially outward with both feet to maintain the surface tension for a limited amount of time.